Hi dears, welcome to another video session of JEE Mantra Series Chemistry Test 2 Recap. I hope last exam was very easy. In this session, we are going to mainly discuss about three topics: chemical kinetics from physical chemistry, D and F block elements from inorganic chemistry, and biomolecule from organic chemistry. Yeah, we are going to do it, okay? So we have to crack the JEE 2025 examination. For that, up to that, we will be there. That you have to keep it in mind. We are going to do the recap. Are you ready? Yeah. In this first chapter, chemical kinetics, we have to mainly discuss about rate of reaction, factors affecting rate of reaction. We have to concentrate. We have to focus mainly that thing, rate law and molecularity and order of reaction. Okay, in every examination, it is repeatedly they are asking molecularity and order of reaction. Then integrated rate equations of zero order, first order and nth order, okay, second order and nth order. Similarly here we have to learn about half-life period of zero order, first order and nth order, then effect of temperature, then effect of catalyst, then collision theory, then state transition diagram. These are the important ideas we have to cover up, okay? Yeah. So here, firstly, mainly you have to remember what is rate of reaction. Rate of reaction means if we are having a reaction, reactants react to give what? Products. So the reactant will decrease and product will increase. So the rate of reaction is defined as what? Either decrease in concentration of reactant by time or else increase in concentration of product by time. Okay, that's the idea. By using that, you are actually dividing this rate in two ways: R instantaneous as well as R average. If you are finding the rate of reaction within a short time interval, then that will be instantaneous rate. Large time interval, that is average rate. By using this concept, they can ask a lot of questions. Okay, so you have to remember concentration by time. That idea you have to keep. Anyhow, the rate's unit is mole liter inverse second inverse. Okay, mole liter inverse the unit of what? Concentration, and second inverse is the unit of time. So concentration by time, mole liter inverse second inverse. You have to keep it in mind. Okay, yeah. Next, from here you have to remember about rate law. So if they are giving any reaction, so here they given AA plus BB gives CC plus DD, then rate law we can write it as rate is equal to K into A raised to need not to be that reactant coefficients. It may or may not be that reactant coefficient raised to X, B raised to Y. I am writing this X and Y may or may not be equal to stoichiometric coefficient. That only this rate law is telling how the rate of reaction depends on the concentration. Okay, so rate of reaction is directly proportional to product of molar concentration of reactants, and some terms are raised to be its power, which may or may not be equal to stoichiometric coefficient. This stoichiometric coefficient, this power's value, we cannot tell by looking at reaction. Either they have to give the reaction mechanism or else we have to conduct the experiment. So the experiment they will give, then only we can find out. This X plus Y is called overall order of reaction. That's the experimental quantity. Okay, that idea you have to keep it in mind. From here, that related questions will be there. Okay, yeah. Next again the idea order and molecularity difference. Order is what? Order is the sum of powers of concentration terms expressed in the rate law equation, and molecularity is the number of components. Okay, number of components. I mean atoms, ions or molecules. Okay, reacting species, atoms, ions or molecule that collide simultaneously in a chemical reaction, in an elementary chemical reaction. That is what's called molecularity. This order value may be either positive or negative or zero. That is possible. But here molecularity cannot be zero. Its possible value is 1, 2, 3. That you know. Okay, that you know, because it's a experimental quantity. It is what? It is a theoretical concept. That idea you have to keep it in mind. This order of molecularity is only applicable to elementary reaction. This is applicable to elementary as well as what? Complex reaction. That much idea you have to keep it in mind. That related question always they are asking once they are giving what? Once they are giving the idea related to this molecularity and order, that time you have to do it. They will give you the mechanism and all. From that mechanism they will ask what? The order molecularity idea. One more thing you have to remember, if they are giving the mechanism, then the slow step. In slow step, what will be the stoichiometric coefficient? That will be the rate law. While we are rating that reactant concentration power we are rating now, that we have to rate the same. Example, let me show you. If suppose this is the reaction A2 plus B2, okay, A2 plus B2 gives 2AB. This is the reaction we are having. Okay, this is the reaction we are having. So, but the problem is that in this reaction they are giving, okay, suppose they are giving what? The mechanism they are giving. They are giving the mechanism like what? Mechanism they are giving. I mean, this reaction is taking place like what? First A2 is there. This A2 is reversibly gives A plus A. This is a fast step. Okay. Then again in step 2, the one among the A that is reacting with the B2, and they are giving what? AB plus B. This is the slow step. Okay. This is the slow step. And again, this B is reacting with another A. Then they are giving AB. That's the fast step. Okay. That's the fast step. So if they are giving this one, means out of that complex reaction, this include more than one step. Each are elementary reaction. Okay. In this elementary reaction, in this each elementary reaction, the slow step is the rate determining step. From that, their order is 1 plus 1, 2. Molecularity also 1 plus 1, 2. So order and molecularity will be same for the slow step. That idea you have to keep it in mind. So once we are rating the rate law, rate is equal to, I can write rate equal to K into A raised to 1 into B2 raised to 1. Like that I can write, but this A is not there, that we have to substitute. Okay, that we have to substitute from the other equation. We have to substitute and find out. So here that stoichiometric coefficient we can write. Okay, the molecularity is 2. But order is not exactly 2, that we will get it as 1.5. Okay, that kind of questions will be there. That idea you have to keep it in mind. Sir, how this is 2? How this is 1.5, sir? Yeah, let me show you that one also. Here in this case, we wrote like what? Rate is equal to K into concentration of A into concentration of what? Here you wrote concentration of A into concentration of B2. Okay, B2, you wrote like that. But this A is not there in our main reaction. To avoid that, they will give what? An reversible reaction. You can see that here. So here equilibrium constant for that reversible reaction is concentration of A into concentration of A divided by concentration of A2 you will get. From that you can find out what? Concentration of A equal to root K. Okay, root K. You can find out root K into A2 raised to 1 by 2 you can write. So instead of that concentration of A, you can write what? K into, this is actually rate constant, this is equilibrium constant, into, instead of concentration of A, what you can write? Instead of concentration of A, why we are eliminating concentration of A? Because A is not there in our main reaction. A2 is there. A2 is different, A is different. A is what? A is actually the intermediate form, that we have to avoid it. For that only this one. Okay. So root K into, we can write K dash into A2 raised to 1 by 2 into B2. Okay. This one K into equilibrium constant. Okay. K into equilibrium constant is a new constant. I will call it is K dash into A2 raised to what? A2 raised to 1 by 2 B2. So the overall order of the reaction is 1.5 will be the overall order of reaction. Anyhow, that kind of question they can ask you, how to keep it in mind. Okay, don't forget the idea. Here we can, what idea I told, we have to conclude it. What? Here along with the A and B2, here along with in slow step, along with the reactants, which value is coming, that we can write it as what? Powers. That's the idea. Okay, ready? We can go to the next one. Next from here we have to learn about what? Integrated rate equation. That related questions will be there. T for zero order equal to R0 minus R by K. R0 is the initial concentration, R is the final concentration, K is the rate constant, and for first order T equal to 2.03 by K log R0 by R. Example also you have to remember, in the case of zero order reaction, all gaseous decomposition over a solid metal surface will belongs to what kind of reaction? Zero order reaction. First order reaction N2O5 decomposition you learned. Then all All what kind of reaction? All nuclear reactions are what? First order reaction that you learned. Then second order is equal to what? T equal to 1 by K into 1 by R minus 1 by R0. That 1 by R, that R means what? R means final concentration. R0 means what? Initial concentration. That idea you have to keep it in mind. By using that, questions will be there. Okay, you have to keep the idea. Then again from here, half-life period of nth order of a reaction. There they given the formula, you can see T half for nth order reaction is directly proportional to 1 by R0 raised to n minus 1. If you put n equal to 1 means first order reaction. In the case of first order reaction, T half is independent of the initial concentration because 1 minus 1 that directly proportional to 1. Okay, so that means T half is independent of initial concentration in the case of first order. In the case of zero order reaction, directly proportional. In the case of second order reaction, that is inversely proportional. Like that idea, you will get that idea. You have to keep it in mind. Fine, ready? Yes. We have to move to the next idea here. The for first order reaction, you have to remember what is T90, what is T99, what is T99.9, what is T99.99. Very easy idea is there. You have to remember T90 percentage is nothing. That's actually 2.303 by K. That is what is, you are having the integrated rate law equation, right? 2.03 by K into log R0 by R. That log R0 by R will go. Okay, it will be 1. It will be equal to 1. So only 2.03 by K will be there for T90 percentage. That idea you have to keep it in mind. Whenever you are seeing 2.03 by K, you have to keep here like what? That is T90 percentage for first order reaction. Then what is T99 percentage? In T99 percentage means how many 9s are there? 2. So 2 times T90. Just to keep it in mind. So then T99.9 percentage means how many 9s are there? 3 9s are there. So 3 into T90 percentage. Okay. So then T99.99 means how many 9s are there? 4 times. So 4 into T90 percentage. This like ideas you have to keep it in mind means that will be easy to relate. And as well as you have to remember what? T75 percentage is equal to 2 times T50 percentage. That kind of relation if you remember means it is very easy. You can solve many kind of problems directly by using this kind of relations if you remember means. Okay, ready? Then here, in this chapter, we have to remember about what? Effect of temperature. That's actually given by the Arrhenius equation. Arrhenius tried to relate what? The rate constant as well as temperature. K equal to AE raised to minus EA by RT. So this is rate constant. This is the Arrhenius factor. EA is the activation energy. R is the universal gas constant. Temperature in Kelvin scale. From that, for different rate constant at a different temperature, we can relate them like this. Log K2 by K1 equal to EA by 2.03 R into 1 by T1 minus 1 by 2. That related questions are coming. If catalyst you are using means this activation energy will change. Activation energy will change, rate will change. That idea how to keep it in mind. Okay, yeah, that related questions will be there. And one more thing, this K2 by K1, okay, K2 by K1 temperature, I mean rate constant at a temperature 10 degrees Celsius higher than with respect to the another one. That means temperature, if you are calculating this rate constant at a temperature 35 degrees Celsius generally, and this one at a temperature 25 degrees Celsius. So the rate constants, the ratio you are taking of, you are taking the ratio of rate constant, they differ by 10 degrees Celsius. That is what is called temperature coefficient. That is what is called what? Temperature coefficient. Its value is normally approximately we usually used to take it as 2. Approximately we usually take it as what? 2. By using that also some kind of question they are asking, they will give a temperature change. Suppose temperature is changing from T1 to T2. Okay, T1 to T2. Okay, 10 degree to 50 degree. Like that they will give. Okay, that means for every 10 degree rise in temperature, the rate of reaction become almost double. That's the idea of temperature coefficient. Whenever you are increasing a temperature 10 degrees Celsius, the entire reaction speed become almost double. So if you are changing T1 to T2, here we will do with one example. Suppose 10 degrees Celsius is the initial temperature. When you are increasing this temperature to what? 50 degrees Celsius. What will happen to its rate of reaction? That's the question. So here the temperature coefficient is 2. Okay, then rate to final is equal to, you can find out by using the formula 2 raised to delta T by 10 into R initial. Okay, this R of means final rate 2. Why I am taking 2? Because temperature coefficient is 2. If temperature coefficient is 3 means 3 raised to. But always it will be, they will be given 2. Okay. Yeah. So 2 raised to delta T. Delta T means change in temperature. Divide by 10. Because 10 degree change only we are calculating into R initial. So that means 2 raised to delta T means what's the change? 10 become 50 means 40. 40 divided by 10 into R initial. That means 2 raised to 4 into R initial. That means 2 raised to 4 means 16 times R initial. Like that, that relation you have to remember. That related questions also will come. Okay? Yeah. Guys, I hope you are listening properly. Ready? Yeah. We can check about the next idea, collision theory. What about collision theory? According to collision theory, they are telling like that entire product formation is because of the collision. Not collision, not simply collision, effective collision between the reactant molecules in proper orientation. Okay, proper orientation. So, according to that idea, we can write is equal to P into ZAB into E raised to minus EA by RT. This E raised to minus EA by RT means fraction of effective molecule. Okay, fraction of effective molecule. What do you mean by fraction of effective molecules? The fraction of molecule that have activation energy, that can process, that can give what? Products. They are called active molecule. Those who do not have the activation energy is called what? They are called what? Passive molecule. The molecule with the activation energy, they are colliding in a proper orientation with the effective frequency. This actually collision frequency. In 1 second, how many times A and B collide effectively? That's what's called Z. So that is what is called rate. That idea only collision theory is giving. This much idea you have to keep it in mind. Ready, guys? Yeah. Then again, in this chapter, finally you have to remember about what? State transition diagram. That's very important. Whenever consider a reactant react to give product. Okay, reactant react to give product. If it is an exothermic reaction, according to state transition diagram, we can draw the state transition diagram like this. You can see guys, here I am taking what? Energy. Here I am taking energy. That curve you learned. Okay, energy. Here extent of reaction. Okay, extent of reaction I am taking, and initially the reactants have some energy, that is potential energy. That reactant will react to reach what? That intermediate state. Okay, intermediate state, or else activated complex state. Okay, then after that their energy will decrease. This is what is the product. Okay, this is what is the product. Here product's potential energy will be less than that of reactant. That idea you have to remember. Then from here to here, you can see reactants to this activation energy. That is called activation energy for forward reaction. Then the energy difference between this product and reactant, that is what is called delta H, or enthalpy of reaction. And if it is a reversible means product is going back to the reactant, then that is called energy of activation for backward reaction. So in the case of exothermic means this energy of activation for backward will be always greater than what? Energy of activation for forward. In the case of endothermic, this product will be comes on the top. That you have to try it. Okay, correct? Yeah, that you have to comment it in the comment box. Okay, how it will be. This kind of related questions will be there from this chapter. So that's all the idea about the chapter what? Chemical kinetics. You have to go through it. You have to practice a lot of questions from this chapter. Whatever the doubts it is coming, you can comment it on our social media pages. We will make the video for that particular question or particular area. Okay, ready? So dears, after chemical kinetics, we have to go with what? D and F block elements from an inorganic chemistry chapter is not like the mathematical one, but it's actually what? You have to remember, you have to by heart a lot of concept, a lot of reactions here. So you have to go through the idea. If you have the basic logic means you can easily answer it. Okay. Yeah. In this chapter, mainly we have to learn about what? We have to focus about what? Properties of D and F block elements, especially the atomic radius, how the atomic radius is varying, melting point and boiling point, ionization enthalpies, oxidation states, magnetic properties, formation of colored ions, catalytic properties, formation of interstitial compounds, some important alloys. Okay, then some important compounds. Always, okay, whenever we are looking the question from this chapter, always, okay, in JEE sessions, always, they usually used to ask one question from either from KMNO4 or from K2CR207. Their properties they usually used to ask. So I'm giving a 5-star here. Very important. Okay, you have to, without looking this one, please don't go to exam. Please go and don't go and write the exam. Okay, so you have to check this one, you have to learn this one, then go and write the exam. It will be fine for you. Okay, then again F block elements. In F block elements, lanthanoid contraction is the main thing you heard, and the oxidation states. That idea you have to go. Okay, you have to go through it. Then only this chapter will finish. Okay, so now let's look one by one. Here, once we are coming to what? The variation of atomic radius in the case of D block elements. In the case of D block elements, especially in any transition series, the atomic size first decreases. Okay, first decreases, then become what? We are talking about a period. You know the idea. First decreases, then become what? Then become constant, and at the end it increases. Why it's so? You learn the idea also. Here first decreases, since because of that the electrons are going to d orbital. They have weak shielding effect. Automatically effective nuclear charge is increasing. Effective nuclear charge is greater than. Okay, effective nuclear charge is greater than what? Shielding effect. Okay, shielding effect. Automatically the atom becomes smaller and smaller. But once we come to the center of the period, so the electron is coming again to d orbital. So this effective nuclear charge and shielding effect will become equal. Then once we are going to the right, again the electron is coming to d orbital. That times this shielding effect will be more than the effective nuclear charge. So that's why also electron repulsion will be there. Their size will increase. This is the idea. Once we are coming from top to bottom, the atomic size is increasing automatically. But zirconium and hafnium, they are having similar size because of what? They are belongs to different period. Even though they are having similar size because of what? 5th and 6th period have similar size because of lanthanoid contraction. That idea you have to keep it in mind. That related questions also will be there. Okay, that lanthanoid contraction idea always you have to remember. Okay, yeah. Next, again once we are coming to the trends in melting points of what? Transition elements, means there you have to remember this melting point and boiling point directly proportional to how effectively your metallic bond is present in your atom, metal atom. Okay, in the case of D block elements, they have vacant d orbital, they have unpaired d electrons, number of unpaired d electrons, as well as what? The number of the vacant s orbital also, unpaired s orbital also may be there in some cases. Okay, so the idea is here the metallic bond is stronger, means, okay, metallic bond is stronger means melting point is stronger, melting point is more. That's the idea. So metallic bond is directly proportional to number of unpaired electron. Okay, number of unpaired d electron. So in the case of 3D transition series, once you are looking what? Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. This is 3D transition series. Once we are looking, this is actually ending with the D1, this ending with the D2, this ending with the D3, and this ending with the D5. This again D5. This is D6, D7, okay, D8, D10, as well as D10 again. So here number of unpaired electrons, once you are checking, that idea you learned already guys. Here one unpaired electron is there. Here two unpaired is there. Here three unpaired d electrons is there. Here five unpaired d electrons is there. Here again five unpaired is there. Here four unpaired electron is there. Here again three is there. Here two unpaired electron is there. Here zero unpaired electrons are there. So once we are going from left to right, actually it should first increase then decrease. But unfortunately manganese melting point is lesser because of its low enthalpy of atomization. That means this metallic bond is weak actually there. That idea you have to keep. That's why manganese is low here. But once we are going downside, again 3D become 4D, 4D become 5D, enthalpy of atomization is increasing. That's why there what? Melting point is increasing. So the one with the highest melting point is this tungsten. You see this tungsten. Okay, you can see the tungsten. That one only we are using where? In the bulb filament and all. That idea you know. That idea you have to remember. Okay, yeah. Next, from here again we have to remember about ionization enthalpy. Their ionization enthalpy, once we are considering with S block and P block elements, you see here the ionization enthalpies of these elements are high. And in most cases lies between those S block and P block. That lies between S block and P block. Okay, it is greater than S block but less than P block. Okay, so this indicates that transition elements are less electropositive than s block elements because they are greater than ionization enthalpy of d block element is greater than s block elements. Automatically they are less electropositive. They have less tendency to donate compared to s block. Okay, so the reason transition metals have what? Smaller atomic radii. Their size is smaller because of nuclear charge is more. Nuclear charge is more than that of alkali metals. That's the reason. That's why their ionization enthalpy is what? More. And similarly, one more thing, the ionization enthalpy of any transition series increases with the atomic number. The increase is, however, is not smooth, as sharp, okay, as sharp, while we are going from scandium, titanium, vanadium, chromium, manganese like that, is not sharply increasing, okay. The reason, because of there is a relationship between effective nuclear charge and shielding effect that we discussed already before. That idea you have to keep it in mind, okay. Once they are giving the idea, that time you have to check it with that one. If they will tell about this ion is stable, this ion is not stable, that time you have to use this ionization enthalpy concept, okay. Then again, we can look about what? Oxidation state of first transition series. In the case of scandium, they can show a oxidation state +3, only +3. That's the maximum stable state because +3. 3 electrons if they are losing, they will get noble gas. Titanium can show +2, +3, +4. Vanadium can show +2, +3, +4, +5. As well as chromium can show +2, +3, +4, +5, +6. They can show. Manganese can show variable oxidation state +2, +3, +4, +5, +6, +7. That much oxidation state they can show. And what about iron? Iron can show +2, +3, +4, +6 they can show. But mainly in the case of iron, the most common oxidation state is +2 and +3. Okay, +2 and +3 is the most common oxidation. Cobalt means +2, +3, +4. Nickel +2, +3, +4. Copper +1, +2. Zinc is +2. Okay, in the case of iron and all, we don't want to write this one +4, +6. Okay, they are mainly showing what? +2 and +3, and sometimes in that brown ring test, they will show +1 oxidation state. That much idea you have to keep it in mind. Then again, once we are coming to electrode potential variation, you have to remember that is not smoothly, not varying, but here in the case of copper and all, it's positive. That purely related to that electrode potential value. Once you are telling about that one, you have to remember about hydration enthalpy, you have to remember about ionization enthalpy. That idea related to that you learned already. That idea, that related, that way you have to tell. Here copper 2+ become copper. Okay, that is very easy. That means copper 2+ is not stable. Copper 2+ is not stable. That's the meaning here. Okay, that is easily becoming what? Copper, because its hydration enthalpy is not balanced by what? Ionization enthalpy. That idea you have to keep in mind. That's why it's +0.34. That's easily converted to copper. Okay, that much idea. That relations and all. Okay, that idea you have to keep it in mind, because here once the questions comes like this, means see, suppose I am having one metal. That metal is in solid state. That I am converting it to a metal in gaseous state. Okay, for that I need to apply what? Enthalpy of atomization, or else enthalpy of what? Sublimation. Okay, then after that this metal I have to convert it into M+. M+ means I have to remove one electron, M+ gas. For that I have to apply ionization enthalpy 1. Okay, then after only this metal ion is going on soluble in what? Aqueous. That time they are releasing some energy, that is called hydration enthalpy. Hydration enthalpy. Always you have to remember this one. This M+ is stable, means that enthalpy of hydration. Okay, enthalpy of hydration should be greater than. That means releasing energy should be greater than the sum of this enthalpy of atomization plus ionization enthalpy. Greater than or equal to. That should have to balance. I mean, how much energy they are accepting, that much at least they have to release, or more than that. Then only that will become stable. Okay, but in the case of copper 2+, it is not like that. That's why it is not stable. That idea you have to keep it in mind. Next idea, formation of colored compound. These D block elements, their main important property is they can show color in their compound because of the DD transition. Because of the DD transition of electron. That idea you have to keep it in mind. But in the case of KMnO4, in the case of K2Cr2O7, etc., here KMnO4, potassium, manganese oxidation state is +7. There is no D electron. In the case of chromium, it is +6. There is no D electron. In their cases and all, ligand metal charge transfer, LMCT, ligand metal charge transfer causes what? That color idea, that also you learned. You have to go through it. You have to check it. Okay, if you are feeling any area, any topic, no, this idea we didn't learn. Okay, this is a recap video. No, we didn't learn that idea. You just comment that. You just just comment that particular topic. Of course, 100% we will make a video. We will make a short video for that particular area. Don't worry, we will be there along with you. Okay, we are going to crack it. Ready, guys? Yeah. Then that idea, DD transition, that idea you have to keep it in mind. If it is titanium 3 plus, they will usually used to give purple color, vanadium 4 plus blue color, vanadium 3 plus green color, vanadium 2 plus violet color, chromium 3 plus green color, manganese 3 plus violet color, chromium 2 plus blue color, manganese 2 plus pink color, Fe3 plus yellow color, Fe2 plus green color, CO3 plus CO2 plus blue pink color, Ni2 plus green color, copper 2 plus blue color. These are the color variation they are showing. And in the case of which color they are showing, actually see which color they are showing, actually see, you can see here in this case they are actually, normally the electrons are in the lower d orbital, lower energy d orbital. Whenever they are getting energy, they will excited to the higher energy level. That's the idea behind the color. Okay, then they will, higher excited energy level is not stable. They will come back by emitting the energy. So excitation, de-excitation, that is what is called a DD transition. Okay, so that complementary color, one color is one color they are absorbing the complementary color only during the excitement. Which color they are absorbing, its complementary color only. They will what? They will emit. That idea you have to keep it in mind. Again, here once we are coming to the next one, magnetic moment. Magnetic moment, they are having spin only magnetic moment that we can calculate by using the formula what? Mu equal to root of n into n plus 2 Bohr magneton. By using this one, every year one question will be there. They usually used to asking. Okay, so don't forget this idea. They will tell like that Fe2 plus. What is the magnetic moment of Fe2 plus? If it is a coordination compound, means we have to look about what, whether pairing is there or not. Or if they are simply asking about the ion, means no need to think about it. Fe2 plus means iron, means atomic number is 26. Electronic configuration what? Argon 4s2 3d6. Argon 4s2 3d6. Fe2 plus means 2 electrons are missing. So only 3d6. So how many unpaired electrons are there? This is 3d. 3d means 5 orbitals are there. Okay, 1, 2, 3, 4, 5 and 6 electrons are there in that. And but how many unpaired? 4 unpaired electrons are there. You can simply substitute n equal to what? 4 into 4 plus 2. 4 into 4 plus 2 Bohr magneton. That means 4 into 6 Bohr magneton. That means root 24 Bohr magneton. Root 25 is 5. Then root 24 is 4.8, 4.9. Something will come. Options will be there. Like that relation you have to remember in mind. Okay. Yeah. That n is equal to number of unpaired electron. Okay, ready? Yeah, we can go to the next one here. That color, complementary color I kept here. If violet is absorbing, means they will emit yellow. If blue is absorbing, means orange, they will emit. If red is absorbing, means green, they will emit. Okay, that one, that complementary color, that wheel is called what? Munchen color wheel. Okay, Munchen color wheel. No need to remember the name. At least you just remember this idea. Okay, fine. Yeah, we can go to the next one. That is formation of complex compound. These D block elements mainly form the coordination compound, because the coordination compound is actually the continuation of this D and F block element. They can form what? D block elements mainly, they can form what? The coordination compound, because of what? They are having vacant D orbital. So they can gain the electron pair from the ligands. They can gain the electron pair from the ligands, especially because of their size is smaller. Their chase is smaller. So phi is equal to charge by radius ratio. Charge by size ratio, that is higher, means higher the phi value means greater tendency to form coordination complex. That's the concept you have to keep it in mind. Okay, they are mainly majority of the coordination compounds are formed by whom? This D block element. That idea you have to keep it in mind. You learned that more idea were there in the coordination compounds. Okay, that basic idea we are learning here. Then again, formation of interstitial compound. In the case of the crystal lattices of this D block elements, the smaller atoms like carbon, nitrogen, hydrogen can be adsorbed there, entrapped there. That is what is called interstitial compounds. Okay, they are entrapped in between these interstitial sites. That's what's called interstitial compounds. So majority of the compounds can form what? The D block elements can form what? Interstitial compound. That idea also you have to keep it in mind. You just remember, because these things will come as a statement question. That time you must have to remember, yeah, this is possible because of the presence of vacant D orbital. That's the idea. Again, once we are coming to the next idea, in that two important compounds we have to learn. First one is K2Cr2O7. Second one is KMnO4. In K2Cr2O7, the preparation is very important. We are taking FeCr2O4, that we are treating with Na2CO3 in presence of oxygen, okay, and high temperature, red hot in presence of air, you will get what? Na2CrO4. Sodium chromate you will get. That sodium chromate you will acidified with sulfuric acid. That will give you what? Sodium dichromate you will get. That sodium dichromate you will treat with 2KCl. That time, I mean KCl you will treat, you will get what? Potassium dichromate. This potassium dichromate is having what color? They are having, potassium dichromate is having orange color, and sodium chromate. Sodium chromate is, chromate means they are having yellow color. Dichromate means what? Orange color. That idea you have to remember. Then their properties and structure, okay. In the case of chromate, you see, chromate means CrO minus, double bond O, O minus, okay. Here you can see it's having a tetrahedral structure, and here the chromate ion means it's yellow color, okay, yellow color. That idea you have to keep it in mind. And the oxidation state, what about the oxidation state? Once you are calculating, you just calculate the oxidation state. This is actually of the type of CrO4 2 minus. So here X, this is X minus 8 equal to minus 2, X equal to how much I will get? Plus 6 I will get. Here also same. Here in between that chromium, you can see chromium, in between that an oxygen bridge also coming. That's the idea, tetrahedral shape itself. That's a dichromate ion, okay. That idea you have to remember. Then again, once we are coming to the potassium permanganate, its preparation also important. That is actually prepared from the pyrrolysite ore. Pyrrolysite ore is MnO2. MnO2 you can treat with KOH in presence of oxygen. Okay, you will get what? K2MnO4. That's called potassium manganate. Or else MnO2 you can treat with K2CO3 and O2. Many ways you can prepare this K2MnO4, potassium manganate. That potassium manganate, from potassium manganate, if you want to convert it into potassium permanganate, means either by oxidation or by electrolysis. Here I given oxidation with what? Oxidation with so many things. Oxidation you can do with what? H2SO4, or else CO2, or else what? Cl2, or else ozone. You can do that oxidation, then you will get what? Potassium permanganate. That idea also you have to keep it in mind. Potassium permanganate as well as K2Cr2O7, both are strong oxidizing agent. Again, in the case of K2Cr2O7, you have to remember a very important test that's called chromyl chloride test. This potassium dichromate, once you are treating with NaCl and sulfuric acid, acidified sulfuric acid, you will get what? This one. This is chromyl chloride. You will get that chromyl chloride is formed is actually what? They are having a red color. That gives that idea is for what? K2Cr2O7. So many things I wrote here. Then once again this chromyl chloride vapors we are dissolved in sodium hydroxide, okay. Sodium hydroxide solution, and then acidified with acetic acid and treated with lead acetate. Yellow precipitate of lead chromate is obtained. This actually given, this test is not given by chlorides of mercury, silver and lead and tin. Anyhow, you just remember that reaction you remember, okay. Chromyl chloride, that formation reaction you remember, how we are getting potassium dichromate once treating with sodium chloride, table salt and H2SO4, sulfuric acid we are using, okay. Yeah, again their main reactions, K2Cr2O7 main reaction, you see, once you are heating, that will become K2CrO4. Once you are treating with KOH in basic medium, they will again go to what? K2CrO, normal chromate, dichromate become normal chromate, okay, normal chromate. And in acidic medium, in with H2SO4, they will be becoming what? CrO3 they will form, okay. Then H2SO4 and concentrated you are heating means they will become chromium sulfate. Simply H2SO4 and cold H2SO4 means they will give CrO3. That idea how to remember. CrO3 they will give. H2SO4 and concentrated heated means Cr2SO4 thrice you will get. Then iodide become iodine, Fe2 plus, ferrous become ferric, okay. Chloride, see, chloride become chlorine. Like that idea how to remember. SO2 becomes sulfate, okay. That idea how to keep it in mind. Similarly, in the case of KMnO4 solution, acidic solution, they will convert iodide to what? Iodine. They will convert iodide to iodine, and Fe2 plus to what? Fe2 plus to Fe3 plus, okay. Fe2 plus to Fe3 plus, ferrous to ferric. That oxalate ion into what? Oxalate ion into carbon dioxide. Like that idea you have to keep it in mind. Again, their structure, this MnO4 2 minus, okay. MnO4 2 minus is what? MnO4 2 minus is actually normal manganate ion. It is having green color, and both have tetrahedral structure. Okay, permanganate as well as manganate. Manganate is MnO4 minus. They are having purple color or also violet color. Okay, that idea you have to keep it in mind. You already did the titration in the lab, I hope so. Okay, yeah, permanganometry you did that time along with the KMnO4. We usually used to add what? H2SO4. H2SO4, but we are not using HCl, because if you are using HCl means this KMnO4 will oxidize that HCl into Cl2. That's why we are using what? H2SO4 acidification, because in acidification, in acid medium, KMnO4 have what? Strong oxidizing capacity. That idea you have to keep it in mind. Okay, yeah. Again, we have to look about the F block elements. In the case of F block elements, okay, sorry, F block elements, oxidation states of F block elements. Here, cerium, preodinium, neodymium, promethium, samarium, europium, gadolinium. Their oxidation state, you just go through it. That's very important. Cerium will show +3, +4, +3, +4. Okay, here +4, +4. Here and all +4 is possible. What? Diomium, thiolbium, that PR, that all can show what? +4. The remaining can show +3. That idea you have to keep it in mind. Okay. Then again, once we are coming to the lanthanoid contraction, in the case of lanthanoid, while we are moving from left to right, the electrons are filling in 4f orbital. 4f orbital have weak shielding effect, so automatically their size is gradually decreasing. That is what is called lanthanoid contraction. And then from here, because after effects of lanthanoid contraction, you have to remember, because of that, lanthanoids are always occurring together. Their basic idea, that basic nature, what is happening to basic nature, that much idea you have to keep it in mind. You have to go through it. Okay, this is a recap video. You must have to go through it. Okay, ready? Then that's all the idea about the chapter F block, D and F block element. There, one more thing you have to remember. I forgot to tell about Misch metal. Also, you have to check it. What is Misch metal? That idea and all. Then which all are the transuranic element related to that? Also, sometimes they are asking questions. Okay, dears. Next, we have to learn about biomolecule from organic chemistry area. So here also maybe the students, okay, they are actually feeling some kind of problem here because so many things they have to by heart. Don't worry, okay, you just go through it. You just write and learn. Okay, again you write and learn. You try to solve so many problems, automatically it will be printed over here. Don't worry. Okay, yeah. So here in biomolecule, mainly we have to learn about carbohydrate, protein, hormones, and vitamins and nucleic acid. Mainly they usually used to ask the question from carbohydrate and nucleic acid. That two area they usually used to ask mainly the questions. Okay, here also questions are coming, proteins also questions are coming, but mainly focusing on carbohydrate. Okay, anyhow, carbohydrate, protein, nucleic acid, that you must have to go through. Okay, yeah. Anyhow, here first thing, carbohydrate, they are sugars as well as non-sugars. That sugars are monosaccharide and oligosaccharides. Monosaccharide, aldose, ketose. Okay, aldehyde containing. So os means what? Sugar. Okay, aldose, that is aldehyde group. Here ketone groups are there. That is monosaccharide, like what? Glucose, fructose, mannose, galactose, like that, only monosaccharides. Oligosaccharides may be either, it may be disaccharide. Disaccharide means sucrose and all, trisaccharide, tetrasaccharide, or polysaccharides. Polysaccharide means many monosaccharides combined together to give you what? Polysaccharide, like starch, glycogen and all. Okay, they are the polysaccharides of glucose. Many glucose molecule combined together to give you that idea. Okay, yeah. So that much idea there. Which monosaccharide is which disaccharide on hydrolysis, which monosaccharide is giving that idea, that conversion and all, their structure and all. Try to learn at least glucose and fructose and their sucrose structure and all. Try to remember. Okay, minimum you have to remember the structure of what? Glucose and fructose. Okay, don't forget that idea. Then here I am giving the epimers of glucose. This actually glucose, glucose here, because of this hydrogen shift, they are having cyclic structure. See on the topmost carbon, that ano means topmost. Okay, topmost carbon, the OH is in the right hand side means alpha. OH is in the right hand side means alpha. OH is in the left hand side means beta. That idea you have to keep it in mind. So alpha D plus glucose. This D actually we are telling by using this one, the fifth carbon. Okay, the second last carbon, that OH is in the right hand side, this D. Okay, that related to lactic acid format and all. So here this is D. Okay, OH is in the right hand side, D, and plus means that is what? Dextrorotatory. That idea glucose is dextrorotatory only. Beta comes from here, epimers. Okay, that idea you have to remember. From this epimers only you are learning about what? Mutar rotation. In the case of alpha D glucose, when you are dissolved in water, it slowly changes its specific rotation from plus 112.2 degree. Okay, Okay, see, it's plus alpha D glucose, its mutar rotation is 112.2 degree. Actually, it's a positive rotation. That means whenever plane polarized light is passing through this solution, that will try to rotate the plane polarized light towards what? Right at an angle of 112.2 degree. Once you are dissolving this one in a aqueous solution, okay, what is happening? What they are telling? Its value will be changed from plus 112.2 degree to 52.7. When pure beta D glucose is dissolved in water, its specific rotation is changes from where? From plus 18.7. Its value is plus 18.7 only. That also changed to what? 52.7. Okay, that also changed to what? 52.7. In NCERT they given what? 52.5. Okay, no problem. 52.7. Okay, 52.7 degree. So that means whatever, either it is alpha D glucose or else it is to be beta D glucose. Whenever you are putting in water, they already cyclic structure is there. The cyclic structure will open. So then they will come to they come to an equilibrium value plus 52.7. That is what is called mutar rotation. That's what's called what? Mutar rotation. That idea you have to keep it in mind. Okay, you have to remember that mutar rotation. Okay, then again after that, there is ozazone formation. Ozazone formation. Oza means already what? Os means what? That is sugar. Zone means actually hydrazone. So the glucose and all, they can react with the 3 molecules of phenylhydrazine in presence of a catalyst. They will form what? An ozazone they will form. Okay, plus aniline will be there, plus ammonia will be there. That idea you have to keep it in mind. Here, how many phenylhydrazine molecule you are treating? 3 phenylhydrazine molecule you are treating. One among them will go and react here on the top. Second one will be react here. Third one will be break and it will be producing what? And it will be producing aniline and what? Ammonia. That ozazone formation is important. You have to keep it in mind. Okay. The Fisher only explained about that. Okay. Yeah. Next one, amino acid. There in where? In carbohydrate and all, you have to remember again about starch, glycogen, how the starch is forming, amylopectin, amylose. That idea you have to remember. Okay, how it is forming, where the bonds are connecting, glycosidic linkage. That whole idea you have to go through it. Then again we are coming with amino acid. Amino acid means amines as well as acid. Alpha amino acid mainly we have to learn. Carboxylic group is there, amine group is there. That is connecting with the carbon and H. Then some R group will be there. Whenever the R group is changing, the amino acid will change. Total 20 amino acids are there. Out of the 10 are essential, 10 are non-essential. That idea also you have to keep in mind. The all amino acids are what? Optically active except glycine. In the case of glycine, that is not optically active. What? CH. Here also H is coming. Then COOH. So that carbon is not what? Not chiral carbon. So they cannot. This is actually glycine. Okay. So that's not optically active. That much idea. Then among them. So here these are the non-essential. These are the essential amino acid. Non-essential amino acid means you don't want to take it by food and all because it's already preparing in the body. Essential means that you have to take through the food because it is not available in the body. You have to take through the food and all. So glycine, alanine, serine, tyrosine, cysteine, asparagine, aspartic acid. Okay. Then glutamic acid, glutamine, proline. And here once we are coming to essential amino acid, valine, leucine, isoleucine, threonine, methionine. Okay. Methionine. Then arginine, lysine, histidine, then phenylalanine, tryptophan. That much idea you have to remember. So that at least that's essential amino acid you remember 10. Then the other thing is asking me, they will ask the questions like this, which one of the following is non-essential? If you know all the essential means the non-essential you can easily identify. Then you have to remember from that which is basic, which is acidic, which is neutral. That much idea. Acidic and all comes with acid. Like that terms will be ending in, that will be acid. More COH group means acidic. More NH2 group means basic. And NH2, the number of NH2 as well as number of COH groups are same means they are what? They are neutral. That idea you have to remember. Again, you have to remember about the isoelectric point. For JEE, they are asking about a question from here. The isoelectric point, okay. Isoelectric point. The isoelectric point of an amino acid is the pH at which it has no net charge. It has no net charge. All charge is actually neutralized. That is what is called what? That's what's called isoelectric point. So example I will give you here. I already gave here. You can see alanine. In the case of alanine, you can see COH in acidic medium. That H is not losing. Okay, this become NH3 plus. Its pKa value is 2.34. Its pKa value is 9.69. then its potential of that isoelectric point you can calculate like what? 2.34 plus this value, this pKa plus this pKa, its average you can take, that will be the isoelectric point. That idea, how to keep it in mind. That related question will be there. Then again the structure of protein, primary structure, secondary structure, tertiary structure and quaternary structure. In secondary structure they are having beta pleated sheets as well as what? Helical structure. That helical structures are connecting with what? In the case of so many amino acids combined together to give you the entire protein. In that protein, what kind of linkage is there? Peptide linkage is there. That idea, you have to keep it in mind. So here in this helical structure, they are connecting with what? Intramolecular hydrogen bonding is there. Okay, in between that hydrogen bonding is there. That idea, you have to keep it in mind. Disulfide bond is there. That also you have to keep it in mind. Here also you can see they are connecting with the hydrogen bond. Here also hydrogen bond. So that idea, beta pleated sheet and all. Then in tertiary means that may be either globular or it may be what? Fibrous. That idea, with example you have to go through it. Okay. Then again, once we are coming to hormones, hormones are also biomolecule which are produced in the ductless, I mean endocrine glands, and are carried to different parts of the body by the bloodstream where they control various metabolic processes. Okay, you know the hormones. So many types of hormones are there. These are required in minute quantities, and unlike fats and carbohydrate, these are not stored in the body. Whenever it is required continuously, it is producing. It is not storing. Okay, these are the types of hormones. First one is steroid hormone. Second one is amine hormone. Third one is peptide hormone. Just to remember at least the types. Okay, steroid hormones means male hormones as well as female hormones are there. In the case of male hormone, testosterone is coming. Okay, female hormone, estrogens, estrone, progesterone, all are coming. Okay, then amine hormones, amine containing hormones are there. Epinephrine, thyroxine are there. Okay, then in the case of peptide hormone is oxytocin and vasopressin, insulin, glucagon. And all, they are the what? Peptide hormones, where they are producing. That no need actually for us. We need what? That names we need, which kind they are actually. That like that question they usually used to ask. Okay, you have to keep it in mind. Again, once we are coming to vitamin, they are means vital minerals are called what? Vitamins. There are a lot of vitamins are there. Mainly they are dividing it into two: fat soluble vitamin A, D, E, K, and water soluble vitamin B complex and vitamin C. They are water soluble. That's why they can go through the excretion. So we have to take it again. This vitamin C and all in citrus fruits and all, it's available. That idea, you know. Here I gave what? The complete table. Here you have to remember. Here from where we are getting that and all I given. You don't want to go through it. At least vitamin B1. Its name is thiamine. If it is less means beriberi will come. The deficiency. That idea you have to remember. Vitamin B2 is called riboflavin. If it is less means chelosis will come. Chelosis means cracking in the mouth and all. Okay. Then vitamin B3. If it is less means dermatitis will come. Like that you have to remember. Vitamin B5, nictotic acid or niacin. Okay, if it is less means pellagra, shriveled skin will come. And vitamin B6. Okay, vitamin B6 means if it is less means dermatitis or anemia will come. Again, vitamin H, folic acid, vitamin B12, cyanocobalamin. In that cobalt is there. That idea you have to remember. If it is less means pernicious anemia will come. Here in all vitamin B, nitrogen is present. That idea you have to remember. Nitrogen is present. Okay. So then vitamin C. Vitamin C is ascorbic acid. Its name is ascorbic acid. If it is less means which disease will come? Scurvy will come. Scurvy. That idea. Which vitamin? Its deficiency. It will cause which disease? That like that you learn. Okay. If it is vitamin A, that's called retinol. If it is not available, if it is not available in the body in a required quantity means what will come? Night blindness. Xerophthalmia will come. Okay. Then vitamin D. Vitamin D is called ergocalciferol or calciferol. If it is less means rickets will form. Vitamin E is less means sterility or impotency. Okay, that will be directly affected your reproductive system. That idea. Then vitamin K is less means hemorrhage will be there. Hemorrhage means blood clotting will be, the time will take that time will take a lag in the blood clotting. That idea, which vitamin its deficiency will cause this one, this vitamin its deficiency will cause that, like that you learn, means that is going to be, if it is asking, means you have to match the column, like that questions may come. That time you, means at least the many things, main things, if you remember, means you can easily answer it, guys. You can easily answer it. Okay, yeah. Next, again in this area we have to remember about enzymes, different enzymes, and where we are using. So the zymers that you learned in the case of fermentation of glucose or fructose to ethyl alcohol, that is actually zymers. Okay, then inverters means sucrose is converting it into glucose and fructose. They are inverters, since because of that glucose is what? Glucose is dextrorotatory, fructose is what? Levorotatory, but our sucrose is dextro, but after the reaction fructose will be more levorotatory. That's why it is called inversion. That idea you know. Invert sugar also, that idea you know. Then again maltose is converting to maltose. Here it is, enzyme is maltase. Okay, maltase, that convert maltose to glucose and glucose, 2 molecule glucose you will get. Lactase means lactose will convert it to glucose and galactose. And amylase means amylase is present in our what? Saliva, that will convert. Amyla means starch will be into what? Glucose. And urease will convert urea into ammonia and carbon dioxide. Pepsin will convert proteins to alpha amino acids. Trypsin will convert proteins to alpha amino acid. Nuclease will convert DNA, RNA into nucleotides. And lipase will convert oil or fats into glycerol plus fatty acid. This conversion you remember. Okay, yeah. Next again we are going to nucleic acid. Nucleic acids are actually, they are the prosthetic groups of nucleoprotein. They are actually called prosthetic groups of nucleoproteins. These are the natural biopolymers made up of by nucleotide units. So they are actually polynucleotide. What is this nucleotide? Nucleotide is actually contain nucleoside and phosphoric acid. That means H3PO4 or phosphoric group. PO4 3 minus group is there. This nucleoside again contain two things. First one is nitrogenous base as well as what? Nitrogenous base as well as sugar, especially pentose sugar. Pentose sugar will be there. That pentose sugar may be either it may be ribose or else deoxyribose. In RNA it is ribose, in DNA it is deoxyribose. And this nitrogenous base may be either purine base or else pyrimidine base. Purine base is adenine and guanine. Pyrimidine bases cytosine, uracil and thymine. Okay. Then once we are coming to DNA, RNA, their difference you have to remember. This pentose sugar is 2-deoxyribose. Okay, this one pentose sugar is what? Simply ribose. Okay, in the ribose, the second carbon oxygen is not there. That is what is called 2-deoxyribose. DNA occurs in the nucleus of the cell. This one is occurs in the cytoplasm of the cell. And the component bases of DNA are adenine and guanine. Adenine and guanine is there. Here RNA are adenine, guanine, cytosine, uracil will be there. Instead of that uracil, here thymine will be there. Thymine will be there. That idea you have to remember. Then DNA has double helical structure. Here RNA has single helical structure. And it direct protein synthesis, stores, transfers and genetic transformation. Their duty. And it's help for protein synthesis. That much idea you have to remember. And you have to go through the what is mutation, that and all idea. Some basic terms related to this DNA, RNA also you have to go through it. You have to check it and you have to go through, if possible means, if you have the time means, enough time means, you have to go through the structure of that what? That nitrogenous base also, structure also you have to just go through it, as well as the structure of proteins, amino acid also you have to go through it. You just read it again, continuously. Once we are going through the same thing 2 or 3 or 4 times, we are going through that one, means we can remember the ideas. You can do it, guys. We will do it, guys. We are going to crack the 2025 JEE mains. January session itself, we are going to crack it. I will be there along with you with chemistry. Okay, so write your exam with that much confidence. Don't blindly answer any questions. Okay, don't blindly answer. If you are okay, then write it. And if you are not agree, just leave it. After, then you can check the answer key, detailed discussion you can see. Then again, if the same question comes means, or same type of question comes means, don't miss it. Okay, we are going to do it. So thank you so much, guys. See you in the next video. Thank you.